Once again, welcome to our series on linear programming. Previously, we saw that linear programming is a mathematical technique to work out the best solution to a problem from a range of possible solutions and within certain limits called constraints. If we have to solve a problem, we must find the possible solutions or answers for the problem. Together, all these answers make up the feasible region. In today's lesson, we will find out how to find the feasible region for a given problem. By the end of the lesson, you should be able to explain what a feasible region is and determine a feasible region using point-by-point plotting. Hi.
Sorry to bother you at home, but I have a problem.
No, it's okay. I need the break. Come. So, what's the problem?
I want to watch the soccer with my uncle this Saturday, but there's so much that I have to fit into the morning. I don't know how I'm going to get all of it done. I've got a project which I have to finish for Monday, so I suppose I should do my homework first. But I've also made plans to play soccer with my friend from next door. There's a replay of the game between Bafana and Burkina Faso on TV, which I want to watch. And I want to go to the Spaza and spend my pocket money.
You're right, that's a lot to do. You'd better start your day really early.
But I like to sleep in on Saturday mornings.
Many of you would have had to make these choices on a weekend. How do you think MacGyver could split up his time this Saturday? There are linear programming techniques that can handle all these options, but the method we are going to use limits us to 2 or 3 options. So for our lesson, I'm going to put MacGyver's problem like this. He must decide how much time to spend on homework and how much time to spend on playing soccer. Why don't we go inside and see if we can work out the solution to this problem?
Good idea.
Well, let's write your problem in a structured way so that we can explore it mathematically. First, we're going to decide what things are going to limit your time. To start with, what time are you planning on getting up in the morning?
Well, usually I get up at 9 in the morning. But today I can wake up early, say about 7:30.
Fine, we can work with that. Now, how much time do you need to get washed and have breakfast?
I usually take about an hour or so. And me and my mother like to catch up over breakfast.
Great. The third thing we need to put down as a limit on your time is that at 11:30 you are going to watch a soccer game with your uncle. Now let's stop there and think about the problem so far. How much time do you have left in your morning for playing soccer and for homework?
Well, it looks like I'll have about 2 to 3 hours.
How did you come to that conclusion?
If I get up at 7:30, then I'll have time until the soccer game at 11:30. That's 4 hours. But I lose 1 hour for washing and breakfast. That leaves me with 3 hours. If I only get up at 9 o'clock, I would still need that hour for washing and breakfast. So I'll be left with an hour and a half.
Well done. Now, depending on whether you get up at 7:30 or 9 o'clock in the morning, you'll have between 1.5 to 3 hours for you to use. Is there anything else we need to consider?
Well, I should spend my time on homework, but I'd love to play soccer for as long as I can.
How about this? Spend at least as much time playing soccer as you spend on homework. It is the weekend after all.
That sounds good to me. So I can spend the same time or more on soccer than homework.
Yes, and you could write that as soccer time greater than or equal to homework time.
But Doesn't that mean I could just play soccer all morning? That will still be more time for soccer than for homework.
Yes, but didn't you say you have a project that you need to hand in at school on Monday? How much time do you need for that?
I'm nearly done with it, so I think I'll need at least half an hour or so.
What we've put down so far are all the constraints on your time. In other words, these are the limits on your decision on how you're going to spend your time.
So now that we know all of this, how do we work out the best use of my time?
We need to look at all the possible combinations of time on soccer and time on homework. One of the ways to do this is to use a grid of points. Each point on the grid can represent a different combination of time spent on soccer and time spent on homework. You have a total of between 1.5 and 3 hours to use. I've put in enough points for up to 4 hours on the grid. I've also divided the possible time up into half-hour slots. I've done it this way because if we had to decide about every minute of your plan, we would need to put many more points onto the grid.
That's great. Half-hour slots work well for me.
Good. Now let's look at this point on the grid. It represents 1 hour of homework and 2 hours of playing soccer.
Let me try that. This point corresponds to 1.5 hours of homework and 3 of playing soccer.
You've got it. Now,
Hold it. I see a problem. 1.5 hours of homework and 3 hours of playing soccer adds up to 4.5 hours. But there are only a maximum of 3 hours available.
you're right. That point on the grid isn't possible. It isn't a viable option. The choice of playing soccer for 3 hours and doing homework for 1.5 hours isn't possible. So let's cross off that point. The grid represents combinations of time spent on homework and time spent on playing soccer. Not all the points are valid for the constraints that we have set on your total time. Let's identify the other points on this grid that aren't possible. The one we've crossed had too much total time, so let's put that into a key.
Here's another point with too much total time. This point represents 0 hours of homework and 4 hours of soccer. 4 hours is more than we've got.
Right, so you can cross out that point with the same color. It's not a viable option.
Actually, this point has another problem too. We said I had to do at least half an hour of homework.
Quite right. So there are 2 reasons why we can't use this point on the grid. But we'll come back to that. For now, let's focus on the points that represent too much total time.
Okay, I think we can just cross out the top 2 rows of points. Each of the points in this row represents 4 hours of soccer with different times of homework. And each of the points in this row represents 3.5 hours of soccer with different times of homework.
You're right. 4 and 3.5 are both already greater than 3, so we know there's too much total time without adding the homework time. Great. Keep going.
Sure. Well, I've crossed about half of the points on the grid. So what's next?
Well, we'll have a look at all the other constraints to our problem. Remember, we said that you had between 1.5 and 3 hours available, so there are also some combinations that represent too little total time. Like this point here. This point represents half an hour of homework and half an hour of soccer. That's a total of 1 hour, which is less than the 1.5 hours that you have available. So we can cross it out. Let me add this to the key. The green represents too little total time.
I think I can cross out the rest of the points that correspond to less than 1.5 hours of total time. This is pretty cool. Now let's look at another constraint. Can't you cross off all the points that represent less than half an hour of homework?
Definitely, and you found the first one already. It was this point. 0 hours of homework is not enough. Let's cross this point out again, but with a blue Koki this time.
So in the key, blue represents not enough homework time. That means I can cross out the other points that show not enough homework. Now that we've crossed out most of the points, can you see what the other options are yet?
First, let's check that we've considered all the constraints.
Let's see. We've taken care of the available time. We crossed off the points with too little time in green and points with too much time in red.
And we've crossed off the points that didn't fit the homework constraint in blue.
So, that leaves this constraint. I want to play soccer for the same time or longer than I spend on homework.
We need to identify the points that don't fit the constraint. Choose a point that hasn't been crossed off yet.
How about this one? This point shows 2 hours of homework and 1 hour of playing soccer. That's less soccer than homework, so I can cross it out.
Right, it's not a viable option. Let's use a yellow Koki this time. In the key, I'll write not enough time for soccer.
What about this point? This has 2 hours of homework and 1.5 hours of soccer. So the soccer time is less than the homework time. So I'll cross it out too.
Great.
Right, are we done now?
Not quite. What is left is the points on the grid that show the possible ways that you can divide the time available between soccer and homework.
There are 1, 2, 3, 4, 5, 6, 7, 8 different ways.
Let's check one of these points. This point here represents 1 hour of homework and 2 hours of playing soccer. That's between 1.5 and 3 hours. The homework time is more than half an hour, and the time for soccer is more than the time for homework. So it meets all the constraints. We can check each of the other 7 points, but we can be confident that they will satisfy the constraints. We have systematically crossed off all the points that aren't possible, so we are left with the points that are possible. These 8 points are a collection of all possible solutions. In the language of linear programming, we call them the feasible region.
I think I get it. The feasible region contains all the possible combinations of time spent doing homework and time spent playing soccer.
Yes, the feasible region is all the points that satisfy our constraints. To find the feasible region, we can test points on a grid and cross off those that don't satisfy the constraints. This is known as point-by-point plotting. Let's have a look at the definition we used for linear programming. We've seen that linear programming is a tool, a mathematical technique that can help us when there are many possible solutions to a problem. It helps us to find the best solution from a range of possible solutions subject to constraints. We haven't yet seen which of these possible solutions is the best or optimal solution. We'll leave that for another lesson. Now I have a task for you. Explain in your own words what constraint and feasible region mean. Then use these terms to help you write a description of the technique of linear programming.